In the last video, we talked about a lot of the weird things around JavaScript with type coercion, where it's automatically converting types for you, which can be very confusing. So in this video, I want to talk about how you can avoid that when checking for equality. So let's get a simple example. We'll have const A equals 1, and const B is going to be equal to the string 1. So these are technically different because this is a string and this is a number, and strings are obviously not numbers, but they both have the value of 1. So what we can do is just console.log a equal b, which is how we check equality. If we save, you see this returns to us true, because JavaScript is doing type coercion, and it's converting a and b to both be the exact same type before actually doing this check to see if they are equal. Because if they didn't do that, a string is not equal to a number, so it would automatically return false. But do we always want to do this type coercion? And the answer is no. Generally, you don't want this type coercion because it can lead to really weird bugs. One of the most prevalent bugs in this regard would be 0 and false. If we were to check if 0 is equal to false, you immediately are thinking, duh, they're not the same. These are completely different. But if we save, JavaScript tells us this is true. And that's because these types of these A and B, which are numbers and booleans, get converted to the exact same type, and 0 is essentially a falsy value, which means that it equates to false. Any number is true except for 0 is falsy. So it converts this 0 to false, and B is false, and false are the same, so we get true returned here. This is generally something you want to avoid. You'll run into the exact same problem with an empty string. A string that has nothing in it is a falsy string. So when we save, this returns true because it's converting this to the type of Boolean, which is false. So again, these are technically the same in JavaScript's eyes. So what you want to do in order to make sure you never deal with this weird type coercion behavior is to actually use 3 equal signs. If you use 3 equal signs like this, it's telling JavaScript, I want you to compare these values, but do not convert the type. Now if we save, we get false being returned, because any values that are different types, for example, string and Boolean, or string and number, are never the same. It's always false when you have 2 different types. So now if we go to our example where we had 1 and the string 1, and save, we get false, but with 2 equal signs, we get true. This is why I almost always recommend you use triple equal signs when doing any type of comparison, because it makes you aware of what types all your variables are. And if you actually wanted this to return true, you would convert this string here to a number by doing parse int, and now we get true because it's checking the number A versus the number here for B, and not actually the string. And you're not letting JavaScript do that automatically behind the scenes, because it leads to weird behavior that you're not necessarily expecting. So I recommend always using 3 equal signs when checking the type of different values, and never actually use 2 equal signs, unless you're comparing null and undefined. As I told you, null and undefined are essentially the same thing. They both mean that you don't have a value. But if we compare these with the double equal sign, it's going to return true. They're both the same in JavaScript's eyes, because they both really mean nothing. It essentially converts them both to the same type. But if we do triple equals, since null and undefined are technically different types, they're never going to be equal to one another with this triple equals. So whenever I'm checking to see if something is null, or to see if something is undefined, I always use double equals. For example, if I said A is double equal to null, this is a perfect example where I want to check to see if A currently exists or not, and I'm going to get true here. And it doesn't matter if I use null or undefined, I'm going to get true for both of them. But if I do triple equals, you see this returns false because A is not undefined. It is technically the type of null. So this is just difficult to deal with, so which is why I always use double equals when working with null and undefined checks. Now, one nice thing is that we can actually apply all of these same rules of triple equals versus double equals to the not equals as well. So let's just go back here. We have 1, 2, and we'll check to see if B is not equal to A. If you remember correctly, we use an exclamation point at the front, so we do exclamation point equal, and this checks to see if they're not the same. And if we save, we get true because they're not the same. But something interesting is if we have 1 and the string 1, this returns false, because technically what's happening is it's converting this string to a number. So now we're checking if the number 1 is equal to the number 1, and of course they're equal, so this returns false because we're checking to see if they're not equal. But you don't necessarily want this type coercion, like I've said before. So what you can do is use 2 equal signs at the end. So we have the exclamation point and then 2 equal signs, and that says never convert types. So now this returns true because the string 1 is never equal to the number 1. Anything of different types, like I said, are not equal to one another. So this is why I always recommend using the triple equal sign like this to check equality, or if you want to check not equal, use exclamation point followed by double equals. Essentially, just always make sure you use the one with one more equal sign, because it's going to avoid all of those weird implicit type coercion issues that you would run into before. And again, if you wanted to check to see if A is not equal to null, I recommend doing the not equal here with just one equal sign, because again, you're going to run into the same problems where if A is null, you can see that this returns false. But if A is undefined, again, we're going to see this is equal to false. But if we use this double equals version, it's going to do that non-type coercion for us, and it's returning true, when in reality, if A is undefined, we generally want to do the same thing if it's null or not. So this is why, when checking for null or undefined, just like I've said before, I generally stick with the type coercion, but otherwise, I always say never do type coercion because it just makes things too confusing. Unfortunately, there is no similar thing for doing like a greater than or equal to with two equal signs. This just doesn't exist, but it's generally not a problem you're going to run into, because if you're doing greater than or equal to, you're always going to be dealing with the same type, so you don't have to worry about that type coercion. And that's pretty much all the differences between double equals and triple equals. Just remember again to pretty much always use the triple equals version unless checking for null or undefined. In the next video, I'm going to be talking about nan, which is also called not a number, which is kind of a unique thing in JavaScript, so I can't wait to see you in that video.